The velocity of an airplane is given by this equation here, where a and b are both constants equal to these values. So we're asked first to find the average acceleration and then the instantaneous acceleration at these 3 points. So let's do it. So let's draw a picture first. And I encourage you to try yourself first before I do it, so you can pause and try this problem yourself. But let's look at what we have in part A. So we start at t1 equals 0, and v1 will be 0. Then we end at t equals 25 seconds. So t2 will be 25 seconds. And we don't know the velocity. So that's the first thing. In order to find the velocity at t2, we can use this equation. But we need this velocity because our average acceleration is our change in velocity with time, which is v2 minus v1 over t2 minus t1. So we need to solve for this. Luckily, we have an equation for velocity, and we can simply plug in our time at t2 into that equation. So v2 is equal to our constant a, meters per second cubed, times 25 seconds squared, minus 3 times our constant b, 1.5 meters per second squared, times 25 seconds, plus 2 meters per second. And that gives us a v2, if you plug that all into your calculator, of 1,764.5 meters per second. So quite fast. Now we have v2, which is just this value, and we have everything we need to solve for our average acceleration between t equals 0 and 25 seconds. Okay, so v2 is just what we found, 1,764.5 meters per second minus 0 over 25 seconds minus 0. Note, normally when you're doing your work, you can leave out the zeros. I just put them in just so that there's no confusion at all. Okay, now 1,764.5 divided by 25 rounds to 71 meters per second squared. In other words, our velocity is increasing by 71 meters per second every second. That's what that means. On average, of course. Okay, let's do B. So B, we are tasked with finding the instantaneous acceleration at each of these points, which means when you hear the word instantaneous, you know you're going to have to find the derivative of your equation. So let's find the derivative of the velocity equation. So the derivative, we can just use our power rule. So we're taking derivative with respect to time, meaning we can bring down our exponents from our time variables. So that's 2at minus 3b. And then the constant, of course, is 0. And now we can just plug in our values for each of these points. So our acceleration at 10 seconds will be 2 times our a value times 10 seconds minus 3 times our b constant. Sorry, you can't see that. And our acceleration at 10 seconds works out to 56 meters per second squared, like so. Now we can plug in 15 seconds into here. So we get 2 times 3 meters per second cubed again, times 15 seconds, minus 3 times 1.5. That term is always going to be the same. And at 15 seconds, our acceleration is 86 meters per second squared. Finally, sorry, this should be 20, not 30. 20 seconds, although we could do it at 30 if we wanted. But let's do it at 20. That's 3 meters per second cubed times 20 seconds minus 3 times 1.5 meters per second squared. And that works out to an acceleration of 20 seconds, well, at 20 seconds, of 116 meters per second squared. And so that is both finding instantaneous acceleration and average acceleration. So thank you for watching.